Upgrade complete.
It has begun. For my brothers. No one shall be the wiser. That's a given.
Job's done, job's done, job's done.
Enlighten me. Bidding.
Au piano. Bravo et merci.
YouTube Music Premium 让你完整掌控你的音乐聆听体验，享受零广告，下载音乐并离线播放及背景播放。试试 YouTube Music Premium。
I bid.
Ready to go. Research complete.
Out with it.
Upgrade complete.
My bidding.
Job's done.
Out with it. That's a given.
Job's done.
YouTube Music Premium 让你完整掌控你的音乐聆听体验，享受零广告、下载音乐并离线播放及背景播放。试试 YouTube Music Premium。 YouTube Music Premium 让你完整掌控你的音乐聆听体验，享受零广告，下载音乐并连线播放及背景播放。试试 YouTube Music Premium。
Upgrade complete.
Out with it. It has begun. My brothers,
Job's done. Job's done.
enlighten me.
Upgrade complete. Upgrade complete. Job's done. Job's done.
I bid you.
Upgrade complete. done.
My brothers.
Upgrade. Job done.
One shall be the wise.
Job done. Job done. Upgrade complete.
My brothers.
Job done.
I am prepared. That's all. One shall be
Job done. Job done. Job done. Job done. Job done. Job done. Job's done.
想要零广告、下载音乐并离线播放及背景播放吗？试试 YouTube Music Premium。
I am prepared.
Someone call for the doctor? Upgrade complete.
试试 YouTube Music Premium。
That's a given. My brothers. No one should be
Job done. Job done. Job done. Job done.
enlighten me.
Upgrade complete.
That's a given. My brothers. No one should be
Job done.
My people has begun. That's a given. No one should be the wiser.
Job done. Job done. Job done. Upgrade complete. Upgrade complete.
Research complete.
YouTube Music Premium 让你完整掌控你的音乐聆听体验，享受零广告、下载音乐并离线播放及背景播放。试试 YouTube Music Premium。
Build more farms.
I am prepared.
Build more farms. Build more
Upgrade
farms.
complete.
For my brothers, it has begun.
Job's done. Job's done.
Out with it.
Upgrade complete. Upgrade complete.
brothers, it has been done. That's a given.
Job's done. Job's done. Job's done.
Enlighten me.
Upgrade complete. Upgrade complete. Upgrade complete.
Out with it. Enlighten me.
YouTube Music Premium。
Job's done. Job's done. Upgrade complete. Upgrade complete.
Research complete. That's a given. Has been done. I hope
Job's done.
I am prepared.
Upgrade complete.
I hope
Research complete.
I hope brothers, it has been done.
Build more farm. Job's done. Build more farm. Job's done.
My brothers, that's a given.
Job's done. Job's done.
Out with it.
Upgrade complete.
One should be wise.
Job's done. Job's done. Upgrade complete. done. Upgrade complete. Job's done. Job's done.
No one shall be the wiser.
Job's done. Job's done. Job's done.
I am prepared.
Upgrade complete. Job's done. Upgrade complete.
I think
Upgrade complete.
it has been done.
Job's done. Upgrade complete. Someone call me
YouTube Music Premium 让你完整掌控你的音乐聆听体验，享受零广告，下载音乐并离线播放及背景播放，试试 YouTube Music Premium。
Upgrade complete. Research complete.
Out with it. No one shall be the wiser. It has begun.
Job's done. Job's done.
That's a given.
Job's done. Job's done.
I am prepared.
Upgrade complete.
For my brothers. No one shall be the wiser.
Job's done. Job's done. Build more farms.
Enlighten me.
Upgrade complete. Build more farms. Build more farms. Build more farms. Build more farms. Upgrade complete.
bidding. I am prepared. Enlighten me.
Upgrade complete.
That's a given. I cannot stop there. For my
Job's
brother's
done. Job's done.
out with it.
Upgrade complete. Upgrade complete.
My bidding.
I pledge my done. Job done.
Out with it. I am prepared. Out.
YouTube Premium 是联访到 YouTube， 还能独家观看所有 VIP 内容，让你窝在沙发上轻松追星，免费试用1个月。
What's happening? Yes, what?
Out with it.
Upgrade complete.
That's a given. I am prepared. For my brothers.
Job's done.
I stand ready.
Upgrade complete.
Hi!
Out with it.
Upgrade complete.
It has begun. I am prepared.
Job done.
My bidding.
Bravo, mesdemoiselles. Camille Thomas, nommée cette année dans la catégorie Révélation soliste instrumentale. Et Béatrice Berru, piano. Bravo. Et merci.
YouTube Premium 是零广告 YouTube 外加影片下载，让你随时随地观看，免费使用1个月。
done.
Premium 从此零广告，耳朵也可以不受干扰循环播放了。试试 YouTube Music Premium。
Out with it. No one shall be the wiser.
Primed and ready!
Job's done.
I am prepared.
Upgrade complete.
My bidding.
Build more farms. Upgrade complete.
Out with it. That's a given.
Job's done.
No one
Job's
shall be
done.
the wiser. It has begun.
What?
Job's done. Job's done. Job's done. Upgrade complete.
My bidding. Out with it.
Bravo, mesdemoiselles. Camille Thomas, nommée cette année dans la catégorie révélation soliste instrumentale. Et
Job done. Job done.
I've been ready.
Bravo. Et merci.
Upgrade complete.
YouTube Premium 是零广告 YouTube，外加背景播放，让你边看影片边阅读、查资料、购物，免费试用1个月。
Upgrade complete. Research complete.
YouTube 与 YouTube Music 应用程式，免费试1个月。
demand additional lumber.
It has begun. I am prepared.
Job's done.
Yes, what?
My bidding.
Upgrade complete. Upgrade complete.
Out with it.
Upgrade complete. Job's done.
Primed and ready.
Upgrade
I am
complete.
prepared. I cannot summon there.
Job's done.
Out with it.
Upgrade complete.
Bravo, mesdemoiselles. Camille Thomas, nommée cette année dans la catégorie Révélation soliste instrumentale. Et Béatrice Bérou, au piano.
Job's done. Upgrade complete.
school, some of my teachers used an overhead projector for lessons, but you don't see them around very often anymore. In fact, I was pretty surprised that they're still available to buy in some places. They were already going out of fashion when I saw them back then, and they're quite a rarity now. But it's pretty cool how it works. There's a very bright bulb down in the base, which reflects light out onto the surface. And then these light rays are focused through a lens onto this mirror and then reflected onto the wall behind me. And I can share any information I want on here by writing on these plastic transparencies. Now, I'm talking softly in this video because I want this video to fall into the category of ASMR. Now, this is a genre of video that's becoming quite popular, and if you haven't already encountered ASMR videos, well, they have a few intended purposes. One is to help people relax, another is to help people sleep, and everyone needs sleep and relaxation at times, so maybe that's why you can understand it's quite popular. There's another thing that can happen with ASMR. Often when you listen with headphones in, it can give you this slightly tingly feeling in the back of your brain, and so that's why people like it too. Often these ASMR videos are softly whispered, but I'm doing mine more soft-spoken. One of the reasons for that is this projector makes quite a lot of noise. There's a fan in the bottom to keep everything cool, and I'm worried that if I whisper too softly, that perhaps you wouldn't be able to hear me very well above the sound of the overhead projector. I would like to quickly thank Fabulous for sponsoring this video. Fabulous is a pretty fitting sponsor for this video because they also place a lot of importance on relaxation, mindfulness, and self-improvement. Fabulous is the #1 self-care app to help you build better habits and achieve your goals. I think all of us have experience with setting New Year's resolutions that get abandoned pretty quickly, but the best way to actually achieve your resolutions is to break them down into tiny habits, and the Fabulous app can help you stick to them. It was developed by behavioral scientists at Duke University and contains guided journeys to help you achieve your goals. I've been using it to try and set up a morning routine that gives me a bit of momentum for the rest of the day, which I find can make all the difference. There's no shortcut to changing habits, but Fabulous offers a sustainable, long-term approach to change your life by building on small successes. To start building your ideal daily routine, you can click on my link in the description. In the first 100 people to do so will get 25% off a Fabulous subscription. So thank you to Fabulous, and let's get on with the math. I have a plan for today to show you some math questions using the overhead projector, and for it to be a relatively relaxing math lesson or review. For some of you, math might induce a little bit of anxiety, but hopefully this can be a way to boost your confidence or interest just a little bit in, quite a relaxing setting. I've got exam questions from Brazil, Turkey, Australia, India, the UK, and the USA. And this video is going to be the opposite of a speed run. I'm going to be going through the problems quite slowly and in a way that I can talk about some of the fundamental ideas involved in the questions, so that even if these things are quite unfamiliar to you or it's been a while since you did questions like these, that you will be able to follow along with what's happening and what some of those fundamental ideas are behind it. A reason that I picked exam questions to go through is, for me personally, I've always learned quite a lot from watching problems get solved, compared to, just reading about the fundamental ideas. Seeing them actually in action and used in a problem helps me understand the context a lot better. Our first stop is Turkey. This is a question from the 2021 AYT exam, and like many of the questions that I've chosen for this video, it's for kind of an end of high school level or people wanting to gain entrance into university. Now, this question was translated and it's quite circle is always exactly half of the circle. So that vertical distance that we're given is indeed the radius. So let's draw. Own semicircle. On here we can mark what we know. If the sun initially looks like this, then after some time, we just see the top of it. The distance in here was that given by 0.3, and this total distance we knew was 3.9, which means that if we take 0.3 off that, the rest is 3.6. Our mystery distance is this line all the way across here, but since we've cut it in half, if the whole thing were to be called x, this here would just be x over 2, and we can actually draw a right angle triangle right in here. Since it's a semicircle and this distance was the radius, this line here is also the radius of the circle, so is also 3.9. And with that, we have a right angle triangle where we know the value of 2 of the sides, and we're trying to find the third side. For that, we're able to use the Pythagoras theorem. If this is our right angle triangle and one of the shorter sides is A, the other shorter side is B, and the hypotenuse is C, then the Pythagoras theorem says that A squared plus B squared is equal to C squared. For us, A is 3.6, our B is x over 2, and our C is 3.9. These decimal numbers are a little bit messy, but it's not impossible to calculate these squares. Remember, you don't have a calculator for this question. We could go over to the margins and write 3.6 times 3.6. We could do 6 times 6 is 36, carry the 3. 3 times 6 is 18, 19, 20, 21. Add a 0 here. Go on to the next line, 3 6s are 18. 3 3s are 9, plus the 1 is 10, and these would get 6, 9, 2, 1. 2 digits past the decimal place in here, so our decimal point will go between the 2 and the 9, and the answer to that would be 12.96. Again, in our little margin, we could do the same to find 3.9 squared. We'd go 3.9 times 3.9. 9 times 9 is 81. 3 times 9 is 27. Plus 8 will give us 35. Do our next line. 3 times 9 is 27. 3 times 3 is 9. 10, 11. This one will add to give us 15.21. So we've got 12.96 plus x over 2 squared is equal to 15.21. X over 2 squared is equal to, subtract 12.9 from both sides. To mentally find the difference between these two numbers, I'd say, well, this is only 0.04 away from 13, and then 13 is 2.21 away from this, so in total the difference would be 2.25. X over 2 squared is the same as x squared over 4. Times both sides by 4 to get rid of this. We have x squared is equal to 9, and thankfully 9 is a pretty easy number to take the square root of. So I'm going to go with x is equal to 3 centimeters. And so 3 will be the answer to this length in here. Now, I'm sorry to say, but we actually did it the slightly tedious way. There was something that we could have noticed, which would have made these calculations redundant and the algebra a little bit easier. Perhaps, depending on how familiar you are with Pythagorean triples. Pythagorean triples are known sets of numbers that satisfy this a squared plus b squared equals c squared. The smallest one is 3, 4, and 5. Let's take a look at a little bit of a visual proof of that. If I had a right angle triangle where one side is of length 3 and the other side is of length 4, then the length of the remaining longest side will be 5 squares. With the way that the light is projected up onto my wall, things up here look a little bit larger than things down here, but believe me, I've tried to make all these individual squares the same size. Each of these objects represents the side length squared. So 3 squared is this square that's 1, 2, 3 by 1, 2, 3, a total of 9 little squares. 4 squared is 16, so there'll be 16 little squares here. And 5 squared is 25. Pythagoras' theorem is saying that the size of this should be the same as the sizes of these two added together. Here's our 5 squared, and I'm going to go at it with my scissors. From this, I can cut out a 4 by 4 grid. Now I've got the 4 by 4, but let's see if this little remaining grid can be made into a 3 by 3. And there we go, we can see our 4 squared and our 3 squared popping out of that 5 squared with nothing left over. The next smallest Pythagorean triple is actually 5, 12, and 13. So when we were back at this stage, there is a chance that we could have noticed that 36 is 3 times 12, and so 3.6 is 3 times 1.2. And 3.9 is 3 times 1.3. So following our Pythagorean triple, x over 2 would have to be equal to 0.5 times 3. That's 1.5. So x would be equal to, well, multiply by 2, that's 3 centimeters. A faster way to get the same solution that we had before. I don't know if you'll agree that it simplifies the math by much, but people have been using Pythagorean triples to simplify their working for literally thousands of years. We've seen Pythagorean triples used on the world's oldest example of applied geometry on a 3,700-year-old Babylonian clay tablet, which laid out the division of land and boundaries of a field and used Pythagorean triples like 5, 12, 1,000 years before Pythagoras himself was even born. So Pythagoras wasn't the first person to invent this or to find these triples, but the theorem still holds his name. Our next stop is Australia. Now this is an exam question from what is called the HSC Advanced paper, and that is something that would be sat by high school students in the Australian state of New South Wales. The question says, calculate the sum of the arithmetic series 4 plus 10 plus 16 plus ... plus 1354. An arithmetic sequence is a sequence of numbers in which there is a constant difference between each term. So you're adding a constant amount every time. An arithmetic series is what it's called when you add all of these terms together. In general, if we called the first term of our sequence A, then our second term would be A plus D, where D is our difference. In this one up here, it looks like D would be equal to 6. You've added 6 here, and then again here, and so on. The third term of our sequence would be A plus 2D, then all the way up to our last term, which would be A plus, well, how many times have we added D? If this is the nth term at the end, and we started adding D from the second term onwards, then we would have added D n minus 1 times. If you already know the formula to find the sum of any arithmetic series, then you might be able to look at this and plug it straight into that formula. But we're actually going to derive it, so how do you add up one of these things? Well, let's call the sum of our general series here S of n. We're going to add up each term, starting with A, then A plus D, then A plus 2D, all the way to adding A plus n minus 1.
Job's done. Job's done.
My bidding.
Upgrade complete.
I am prepared. Someone call for the doctor?
I stand ready.
Thy bidding. That's a given. It has begun.
Job's done. Job's done. Job's done.
Out with it.
Upgrade
One shall be
complete.
wiser.
Job's done.
I stand ready.
Ready to work.
I am prepared.
Research complete. Upgrade complete.
Bravo, mesdemoiselles. Camille Thomas, nommée cette année dans la catégorie Révélation soliste instrumentale. Et Béatrice Berru.
I am prepared. Thy bidding has begun. That's a given.
Job's done. Job's done. Job's done.
Research complete. Out with it.
Upgrade complete.
One shall be wiser. It has begun. No one shall be wiser.
Job's done. done.
by bidding.
Upgrade complete.
No one shall be the wiser.
YouTube Premium 是零广告 YouTube 外
That's a
加
For my
影片下载功能，让你能在空中边看料理节目边吃飞机餐，免费试用1个月。
It has begun. No one shall be the wiser.
Job's done. Job's done. Job's done. Upgrade complete.
Out with it. I am prepared. For my brothers.
Job's done. Job's done. Job's done. Job's done.
Out with it.
Job's done. Job's done.
What's happening?
Job's done.
Wrecking crew here. What's
All
happening?
gold is required. Upgrade complete.
Primed and ready.
Out with it.
Upgrade complete.
That's a
complete.
given.
免费试用1个月。
What will be
You'll see.
Job's done. Upgrade complete. Build more bombs.
There's so much.
Upgrade complete.
Out with it.
试试 YouTube Music Premium。
Job's done. Job's done.
My bidding
Upgrade complete. Upgrade complete.
has begun. No one shall be the wiser.
Job's done.
Enlighten me.
Upgrade complete.
Storm, earth, and fire, heed my call.
Now what we can do is write out the series again, but this time in reverse. We start with our last term, a plus n minus 1d, and then our second to last term, which would be a plus n minus 2d. Then a plus n minus 3d, and finishing with our first term, a. You often see mathematicians try this technique where they write out the series again but backwards. That's because it allows them to do some kind of cool tricks. One is to add these two series together. We add s of n to itself. Doing that, we would get 2 s of n's. The first term of that would be a plus n minus 1d. Well, what is that? A plus a is 2a plus n minus 1 d. The next term is a plus d plus a plus n minus 2d. And that might look pretty different, but actually what do we have? An a here and an a here, 2a, plus, well, we have n minus 2d plus an extra d. That's actually n minus 1d. And in fact, every term in here gives you that same result. I'm going to run out of room on my transparency, but a plus 2d plus a plus n minus 3d is also equal to 2a plus n minus 1d, and you can see it pretty obviously with our last term too. So in total we have that 2 times s of n is equal to this term 2a plus n minus 1d repeated for however many terms we have. So repeated n times. To get rid of the 2 and get us the expression just for one series, we can do n over 2. And we can simplify it just a little bit more. If we look back to our sequence, the last term is always a plus n minus 1d. And we kind of see most of that in here, although we have an extra a. And, well, a is always the first term. So this can also be written as n over 2, a, which is the first term, plus the last term. Maybe we can call that L. Now that is a derivation of what will always be the sum of an arithmetic series. So let's get to working out our problem. We have what we've derived just here, and we know that, well, there's a constant difference of 6 between each of our terms. So d for us is going to be equal to 6. Our very first term, a, is equal to 4. And our very last term, L, is equal to 1, 3, 5, 4. We don't, however, know our value of n. They haven't told us how many terms there are, so we can't jump straight into using this one. Instead, let's put what we know into this formula here for our last term. If 1, 3, 5, 4 is equal to 4 plus n minus 1 times 6, then subtracting the 4 and dividing by 6, we have 1, 3, 5, 0 divided by 6 is equal to n minus 1. That will be 2, 2, 5. I think you might be allowed a calculator for this exam. This is the Australian one. Is equal to n minus 1. And so n is 1 plus this. N is equal to 226. Now we have n and all that we need to calculate the sum. So s of n is equal to 226 over 2. The first term plus the last term. Well, if we plug all this into the calculator, we end up with 1, 5, 3, 4, 5, 4 as our answer. Well, who would have guessed? That's what it is, adding up all that. This question reminds me of a little story that goes around about the mathematician Carl Gauss. He's known as perhaps one of the greatest mathematicians, and this is a story from the time when he was at school. Apparently, Gauss's teacher wanted a bit of peace and quiet, so he asked the class to add up all the numbers between 1 and 100. As the other students set about adding it all up very slowly and carefully, Gauss almost immediately wrote down the correct answer, which was 5,050. Gauss could perhaps see a formula similar to this one and applied it to the problem. He's said to have imagined it as folding up these numbers in half and then adding up the pairs such as 1 and 100 and 2 and 99. That would be 50 pairs of 101, giving the answer. Or expressed as a formula, the first and last term times n divided by 2. Now this anecdote tends to make the other students in the class sound pretty unintelligent, as if they would add up 1 plus 2 plus 3 and do every single step in order. But I challenge you to imagine doing this for yourself, even if you knew nothing about math or sequences and series and these formulas and tricks. As you go through the numbers, you can't help but see some patterns. In fact, it almost seems difficult to do it in the hardest way. Maybe you'd see that in adding up the numbers between 10 and 19, you'd get the same sum as adding up the numbers lower than that, just with an extra 10 sets of 10. So just because you're not Gauss answering it in a few seconds doesn't mean there aren't lots of ways to solve a problem like this. This next question is from India. Now, often when I've spoken about Indian exams on my channel before, I've spoken about things like the JEE, which is a super specialized engineering focused, really difficult paper for university entrance. But this question here is from the CBSE exams, and in fact the standard mathematics exam for grade 10. Now this isn't even the most advanced paper, we could have gone to grade 11 or 12, but I found that picking the grade 10 one brought it a little bit more in line with some of the other problems I've picked and made it a little bit easier, for this video where I don't want to stress you out too much. So these CBSE exam papers from India are more standard, sort of given to everyone rather than just those people who want to specialize in engineering. So let's have a look at the problem. It says the value of k for which the system of equations x plus y minus 4 equals 0 and 2x plus ky equals 3 has no solution is what? Alright? Equations like these represent straight lines, and when we're talking about solutions of systems of equations like this, we can imagine where the straight lines might intersect. So if we have an xy axis like this, then in the case where, for example, one line might go like this, the other might go like this, we have one place where the lines intersect, and that would represent one solution. We also refer to this situation as being consistent. Let's try another possibility. If we have one line and then another line exactly over the top of it so that you can barely even tell them apart, well, we're going to have infinite solutions. Because since these lines are perfectly over the top of each other, there are infinitely many places where they meet. The situation is also referred to as consistent. And there's one last possibility to consider, and that is in the case where our two lines, one here and one here, are parallel to each other. They're like train tracks, perfectly parallel, and they're never getting closer or further away. They're always staying the same distance apart. In this case, there will be no solutions. The situation is referred to as inconsistent. So in our question, we're asked where these two straight lines have no solution. So really we're asked how we can ensure that these lines will be parallel. We often see straight lines written in this format, y equals mx plus c. This is the slope-intercept format. And here m represents the slope of the line and c represents the y-intercept, so where it cuts the y-axis. For two lines to be parallel, they would differ only in the y-intercept, so they would have the same gradient but just shifted up or down by some different amount c. If c was the same and the gradient was the same, well, they'd be on top of each other. So one way to solve this is to rearrange both these equations into this form and see what you can do to make sure that m is the same for both lines, but that c is different. But this is a question on an Indian exam, and they love to find tricks where you can solve these questions almost instantly. Sometimes that involves memorizing a lot of seemingly random little formulas and equations to solve these quickly. And maybe in the extreme time pressure of exams like this, maybe even rearranging it into this form is way too slow. So let's see where a shortcut might come from. In general, for simultaneous equations in this form, ax plus by is equal to c, often we can solve the equation by adding these two together and hopefully in a way that cancels out one of our variables. For example, if a1 was 1 and a2 was minus 1, then adding these two together would remove the variable x and you would be able to solve for y. If a1 and a2 or b1 and b2 aren't already the same magnitude, we can multiply them by some constant to make sure that they are. We just have to make sure to multiply every term by that same constant. For us, our equations can be written as x plus y is equal to 4 and 2x plus ky is equal to 3. If we multiply the entire top equation by minus 2, then adding these together, we would see the x variables disappear. We would have minus 2x minus 2y is equal to minus 8. That's all fine because we did it to every single term, so it's the same equation. Adding these up, we have 0x, then k minus 2y being equal to minus 5. Now we don't know what k is, but that's the thing we're trying to find. Let's have a think about it. If k was any value except for 2, this would look like a normal equation. We'd have something times y is equal to minus 5. We could find that y is equal to minus 5 divided by whatever this value is. That would represent a consistent set of equations, one where there is one solution. But what if it gets weird? What if k is equal to 2? We'd have 2 minus 2, that's 0. 0 times y is still 0, and we would end up with 0 is equal to minus 5. That is if k is equal to 2. Now, believe it or not, this is actually what we want. Seeing something like 0 is equal to minus 5, well, that is inconsistent. There is no solution to this because, well, think of it like this. What values of x and y result in 0 being equal to minus 5? Well, none. There are no values of x and y that ever make this true. This is inconsistent in the truest sense of the word. So the answer to the problem is actually k is equal to 2. And if you're an Indian student studying for an exam, you probably already know a shortcut way to think about this. It is to say that for no solutions, we want to ensure that the ratio a1 over a2, that's these values here, we want to ensure that is equal to the ratio of b1 over b2. Basically means that when you decide to multiply it by that constant minus 2, that we cancel both our x's and our y's, because these ratios are equal to each other. But we do not want both of those to be equal to the ratio of the constants c1 over c2. That is the shortcut way to find the answer to this problem. So if they had have also been equal to c1 over c2, well, in that case, the constants would have also cancelled out, and we would have been left with 0 is equal to 0. That doesn't represent no solutions. In fact, this is always true. 0 is always equal to 0. So if this is the ratio between all the coefficients, you actually get infinite solutions. Now, I also had questions prepared here from the UK's GCSE and from the American SAT exams, but I'm looking at my camera, it's been filming for a long time. looking at my mic, it's about to run out of batteries, and I'm starting to feel like maybe I've done enough already, so perhaps I'll save those extra 2 questions for a part 2, or if anyone enjoyed this video or made it to the end, let me know and I'll know to keep them for later. Thanks so much for watching this video. I know it's been a little bit different, it's been a little bit of a risk for me to do. If you've been listening to try and fall asleep, then good night. And if you've been watching to relax or unwind, I hope that the rest of your day is positive and not too stressful, that you get some good stuff done. Thanks as always to my Patreon supporters for making my videos possible. And a special shout out to today's Patreon cats of the day, who are very astronomically named, Pan and Tilt.
Welcome back to Science Click. Today, the mathematics of general relativity, part 3, geodesics. In the previous videos, we have defined the concepts of world lines, motion as proper time goes by, and velocity, which indicates the direction in which an object moves through space and time. We would now like to describe the evolution of this velocity as proper time passes, in order to predict the shape of the trajectory. In our universe, objects naturally move in straight lines. When no force is applied, world lines tend to be straight through the dimensions of space and time. This comes from the symmetry of such a trajectory. An object has no reason to turn one way or the other. This simple consideration gives us a method to predict the trajectory of a body. As soon as we know its velocity at a given instant, we can just transport the arrow along itself to gradually predict the movement of the object. This type of trajectory, which is formed by transporting velocity along itself, is called a geodesic. In the universe, all objects tend to follow geodesics. On a geodesic, the vector does not turn. We can thus write that its derivative with respect to proper time is 0. Along the trajectory, derivative with respect to proper time is 0. Along the trajectory, the velocity vector of the apple does not vary. This equation simply says that the natural movement of bodies is non-accelerating, and therefore that when they experience no force, objects tend to move straight ahead. But we saw previously that the velocity vector can be written as the sum of its components multiplied by the basis vectors. Using this expression, and knowing that the derivative of a product is the sum of each term multiplied by the derivative of the other term, we obtain a relation between, on one side, the change in the components of the velocity, and on the other side, the change in the basis vectors themselves. the basis vectors can indeed vary throughout the trajectory, because the grid that we choose as our coordinate system can very well be irregular. Although the vector remains the same as a geometric object, its components on the grid can vary as the apple moves. When we think about it, the evolution of a basis vector along the world line can be decomposed as the sum of its evolution along each of the two coordinates, multiplied by the speed of the apple, because the faster the apple moves, the faster the basis vector will vary. For each coordinate, this gives us a new quantity which indicates how the basis vector varies along the coordinate. This variation is expressed as a vector that is the derivative of the basis vector with respect to the coordinate in question. This vector is very interesting because it no longer depends on the trajectory, but only on the structure of the grid itself. This vector can be expressed through its components, denoted by the capital letter gamma. In our two-dimensional case, these components exist in 8 different versions. 2 components for 4 different vectors. These numbers are called Christoffel symbols. The Christoffel symbols are essential quantities for general relativity because they encode how the grid changes along each direction. They contain crucial information on how our coordinates behave. Rewriting the previous equation using Christoffel symbols, we finally get to the geodesic equation. This very important equation allows us to calculate for each component of the velocity its rate of change as proper time passes. The geodesic equation thus allows us to predict the whole trajectory of an object, as long as we know its velocity at a given moment and the value of each Christoffel symbol all throughout the grid. To illustrate all these ideas, let's imagine not a space-time, but simply the surface of the Earth. We decide to use a latitude-longitude coordinate system, which at first glance seems to be a very good fit for the geometry. Now imagine that an airplane is moving in a straight line. When an object moves straight ahead without ever turning, its trajectory forms what is called a geodesic. In our situation, the geodesic is a great circle around the planet. On this geodesic trajectory, the airplane is always moving straight ahead. Its velocity vector does not change orientation. But when we plot the coordinates, the trajectory seems curved. The airplane seems to change orientation along the grid. In reality, its trajectory is perfectly straight. The problem does not come from the airplane, but from our grid. It's our coordinates that are curved. Their axes do not correspond to straight lines on a sphere. Compared to real straight lines, geodesics, they turn. Starting from a basis vector and transporting it along the grid, we can measure how much this vector changes by another vector. It's the components of this vector that are called Christoffel symbols. The Christoffel symbols measure the extent to which our coordinates deviate from straight lines along the grid.
T0的位置，前4率 58.6%，世界率 16.7%。13.19 边的所有尝试阵容呢，都是有惨遭削弱的，只有艾欧征服没有惨遭毒手。而13.19改版的时候呢，又减少了差雅的一个魔力，增强了征服的羁绊，优化了尼拉的技能，可以说是 T0中的 T0。出装部分，差雅可以去除俄语破防者、死刃、巨杀、科技枪等等的攻击装备。尼拉呢，只是可以去拿艾欧转，没有艾欧转的话呢，你就是出火炮加上嗜血者，然后再加上泰坦这类的一些攻击装备。艾希的话呢，则是可以去拿艾欧转，然后俄语还有死刃以及巨杀。通常会去养到艾希的话，就是你的艾希真的进很多，你才会去养，因为现在的版本之中就很多人在卷差雅嘛，所以你很容易就抢不到艾希，或者说没有办法把艾希刷到3星。所以建议大家就是还是把艾希当做一个过渡角即可。圣跟赛特的话呢，则是可以去除反甲、好战、龙爪等等的一些弹性装备。征服装置比较关键的是艾欧转、征服转、窃取生机以及守望之灵。其他的可以去选择窥基星期5啊，至于领球知己知彼、王者馈赠、理想主义以及社交距离。传说推荐的就是普罗。完成的先决条件的第一个呢，就是你有艾欧转，或者说你有征服转，那或者是说你可能前期就是补艾欧体系的一排，又或者你可能是俄语的一个开局。阵容过渡的部分的这套阵容呢，推荐就是保血量去玩哦。或者是说你可能就是被迫连败时呢，也都是可以玩的。被迫连败的意思就是说，前期真的没有2星角，你就是永远都嫖不到，然后你也没有装备能够去过渡，才去打的连败，而不是说刻意去连败哦。这个时候你在3之5的时候可以去升上7等抽牌温血，因为这种营运阵呢，肯定都是连胜保险最好的嘛。为什么这阵连败能玩？最主要的原因呢，是这套阵容实在就是过强了。只要你有刷到差雅、尼拉就能够锁血，以正常营运的方式呢下去进行即可。2之1呢，你可以去升上4等；2之5升上5等；3之2升上6等。接着在3之7或者说4之1的时候呢，去升上7等。3之7为什么会去升上7等？最主要就是我们要去在野怪的回合提前抢等，然后抢牌。接着来讲一下这阵容常见的一些状况，就是你可能没有艾欧转，因为呢这套阵呢它是需要有转职才能够在7等达成6艾欧的一个体系。如果说你今天是没有转职的话呢，就建议大家可以先去组出下面2种的搭配。第一个是4重装4征服的体系，第2种呢就是4征服3艾欧2弗雷尔卓德。通常我们在7等的时候先组出这样子一个体系，然后要么就是先在这边锁血锁一波，然后等到8等的时候再根据金牌状况去组出6艾欧即可。第二个呢，就是你有艾欧转的一个状况，你就可以直接组出6艾欧4征服。第三个就是你有征服转的话，就可以去组出6征服。这样看下来可能有点复杂，不过呢，基本上就是大家以这个3艾欧4征服为核心去做搭配即可。那你今天有艾欧转，然后艾希也进得多的时候呢，就是可以去选择玩赌艾希。第二套来介绍的是堡垒神域，基本是4堡垒4神域2伊克斯2巨石风，阵容强度约落在 T1 的位置。出装部分你可以去出嗜血者、泰坦、反甲、星火等等的一些坦型装备。比较推荐的3件套就是嗜血泰坦加上反甲。这个版本的反甲基本上就是一个必出神装啦，主要是来克制征服差雅这样子一个体系。所以大家要记得一件事情，就是这个出装呢，有的时候其实会随着版本的变化而改动的。接着索拉卡可以去出精进啊、法爆、大天使等等的一些魔攻装备。比较推荐的3件套就是精进加上大天使还有法爆。他们的话只是可以去拿法爆、科技枪啊、黑书等等的一些魔攻装备。塔里克则是可以去拿星火日炎、赎罪这一些比较带有功能的装备。征服装是比较关键的，就是免费招待券啊、助战神域、旭日晨光以及双胞胎。其他的话则是可以去选择专属魔棒、复苏暖焰，还有珠光莲花就是爱刷建立军队以及治愈灵球。传说依然是推荐普罗。而玩之阵的先决条件呢是比较严格的，因为它毕竟是一个毒狗类型的阵容，建议呢你要有进尼克或者说索拉卡才玩是会比较好的。第二个呢就是没有同行，第三个就是你有双胞胎的时候呢，上限是会再更高的。13.19版本啊，尼克啊、米里欧以及堡垒伊克斯塔尔的体系可谓是4重增强，使得这套神域尼克强度飙升，阵容非常的坦。后排又有索拉卡疯狂补血，一直拿，通通的就会让敌人打到手都要抽筋了。而且这套阵容在7等的时候就能够成型，只刚需1张的4费卡，这造价可谓是非常的亲民。推荐的大家以堡 冒险或者说连胜的方式下去过渡。详细的玩法可以直接参考之前发的这个赌尼克的影片。再来第3套来介绍的是斗士蛇女，这套阵容呢我也是相当的推荐，它所组成的羁绊呢就是6斗士、2伊克斯、2杀戮、2神域、2苏瑞玛，阵容强度约落在 T0 的位置，前4率 59.1%， 吃鸡率 17%， 也是我们本部影片中拿下最高胜率的阵容，这你就知道它有多无脑了。基本上我自己在美服的大师、宗师场啊，就很常会遇到这种有在铁头斗士蛇女的一个体系。科加斯的魔力啊，这版虽然是有被削弱的，输出呢稍显不足，但作为坦克的能力还是有的，加上呢米里欧还有雷克萨都是双双增强，目前的强度还是非常的稳定。出装的部分，科加斯可以去出赎罪啊、反甲、龙爪等等一些坦星装备，蛇女的话则是可以去拿蓝棒、法爆、巨杀、科技枪、大天使、破防者等等一些魔攻装备。如果说你今天看到真的是非常多人都在出反甲的话，那你也可以直接去出大天使、巨杀这样子一个出装方式的话，就是比较不会被那种反甲龙爪的人给 counter， 因为反正6斗的一个体系呢都会打很久，所以很长的就能够去拖到加时赛的一些环节。最后招式最关键的就是斗士转啊、免费招待券、屹立不摇以及耐力训练，其他的话只是可以去选择泰坦之舞啊、治愈灵球、就是爱刷、王者馈赠，而传说可以去选择普罗或是雷星。反正真的先决条件的第一个就是你可能是拿到密林的元素格，第二个呢就是你开局可能就有2星的一个科加斯。通常啊，如果你可能就是2阶段嘛，你就一个2星科加斯，然后又有几张的一个蛇女，那你就可以去往这样子的一个阵容去靠。第3个话就是没有同行，其实任何的一个独偶阵都是这样，你只要有同行的话呢，你那局就会变得相当的难受。这种过渡的部分呢，前期建议就是连败最大化经济，在3之1的时候可以卡4等去刷牌。如果说你的科加斯有望在这个回合呢就去升上3星，则可以直接抽到底，反之你就是抽到剩下32块钱，这个时候你就可以在3之5的时候回存50块钱，然后再慢慢抽我们的鳄鱼啊、蛇女、米里欧、科加斯等等的牌到3星。最慢的话就是到4之1的时候呢，让我们的科加斯以及蛇女都来到3星。从画面中呢，大家可以看出蛇女的伤害真的是非常的惊人。我这一场呢，它是有耐力训练的，所以养到后来呢，我的蛇女血量也是高达了惊人的3000血，都可以拿来当做前排来扛了。而蛇女呢，其实我觉得就算没有3星也没有关系，但是还是要讲一下，就是有3星真的是一个非常大的提升。有一些人呢，没有3星是不放手的。不过我是觉得啊，如果说你今天真的就差很多张，真的就没办法的一个状况下，你的后排输出也可以换成什么阿奇尔啊、畅雅、魔豆啊这些高费卡阵容的灵活度呢，我觉得是非常高的。第4个要来介绍的是刺客炮手，也就是毒葛雷夫，羁绊是4刺客、4炮手、2佐恩，阵容强度约落在 T1 的位置，前4率有 57.3%， 持续率 11.5%。加纳被削弱后呢，我们的新时代接班人也就是我们的葛雷夫了，可以说是恰雅的救急克星，呈现速度呢比基亚纳更快，节奏拉满，给足营运体系非常高的一个压力。出装部分，葛雷夫跟基亚纳都可以去出嗜血者泰坦、那史特拉克手套等等的一些务工装备。再来就是卡特跟艾克的话，只是去出一些魔攻装，像什么法爆啊、正义啊、星火都是可以直接给到他们身上。而新克斯的话呢，只是可以去拿刺客转，还有那都可以去，可以说是恰雅的救急克星。新时代有 57.3%， 持续率 11.5%。加纳被削弱后呢，我们的新时代接班人也就是我们的葛雷夫了，可以说是恰雅的救急克星，呈现速度呢比基亚纳更快，节奏拉满，给足营运体系非常高的一个压力。出装部分，葛雷夫跟基亚纳都可以去出嗜血者泰坦、那史特拉克手套等等的一些务工装备。再来就是卡特跟艾克的话，只是去出一些魔攻装，像什么法爆啊、正义啊、星火都是可以直接给到他们身上。而新克斯的话呢，只是可以去拿刺客转，还有鬼手以及俄语。对我招式比较关键的就是吸血暗刃，还有双胞胎以及免费招待券，还有刺客转。其他的话也可以去拿，就是爱刷、炮手对决、治愈灵球以及珠光莲花。传说还是推荐普，就是爱刷。炮手对决、治愈灵球以及珠光莲花，传说还是推荐普罗。而玩真正的先决条件的第一个就是你的前期葛雷夫进牌够多，并且没有同行。这种过渡的部分呢，前期建议就是连败最大化经济，在3之1的时候卡4等去刷牌。如果说葛雷夫呢有望在此回合去升上3星，则可以直接抽到底，反之就是抽到剩下32块。接着呢，在3之5的时候回存50块的一个经济，再慢慢的存，慢慢抽我们的葛雷夫。 夫来到3星，最慢4之一前一定要让我们的格雷夫达到3星，然后等到我们的格雷夫3星之后呢，就差不多大功告成，你就可以去升上6等了。6等之后，就是看基亚娜进的够不够多，如果基亚娜进的够多的话，你就可以视情况去追到3星。反之进不多的话呢，我们就直接去速7等。7等的话就是去补上4刺客4炮手的一个羁绊，在此慢慢去追艾克啊、卡特啊、基亚娜来到3星。这版本挑战的阵容是减少很多，因为挑战这个东西呢，它是比较好打刺客，毕竟菲欧拉就时不时来一个大反杀，或者说凯撒就时不时就滑走了。现在的版本比较多的都是那种战 A 怪，就是什么差牙、巫师啊、暴冲法师啊之类，就是在那边原地等死的这种角色。所以刺客现在大成之后呢，吃鸡率是变相提高很多。最后一套来介绍就是赌逆命，所属的羁绊有4爆冲、3D 马来西亚、2巫师、2战略，阵容强度越落在 T1 的位置，身死率 52.4%， 吃鸡率 12.6%。这个版本爆冲还有加利欧呢都是双增强的，是一个很好保前4但比较难吃鸡的一套阵容。对方部分的逆命可以去出蓝 buff、法爆、科技枪、死帽等等一些魔攻装备。再呢就是像塔利亚这样子的角色，你也可以去给他出蓝 buff。那如果说你今天真的没有蓝 buff， 就是出精进。第4呢，给大家一个概念，就是爆冲法师它是比较需要那种开场爆发的，所以就会比较偏向去出蓝 buff。不然其实如果你今天魔力是高于60的话，其实你选择精进是会比较好的。不过我们这阵容讲求的就是一个秒杀流，所以呢你有蓝 buff 的话，绝对就是优先去出蓝 buff。再呢法爆啊跟巨杀也都是可以给到塔利亚的身上，加里欧呢只是可以去拿粉甲跟10相轨，基本上我都是这2件去出。那如果说今天真的没有的话，你就去拿什么好战啊、星火龙爪也都还可以。最后这的话只是可以去拿电刀，如果说你今天是前排没有去出星火的话，那你就是要再去出一个电刀。那降防的这种装备你就是出一个即可。唢呐的话只是可以去拿蓝 buff， 唢呐主要就是你开局的时候让它去放技能，然后让我们的全体爆冲法师都得到一个攻速的加成。这真正比较关键的一个增幅就是免费招来券啊、炫技、重拾学习要趁早。其他的话则是可以去拿专属魔杖、烛光演化、治愈灵球、就是爱刷、炼狱之气以及投资报酬。所以说比较推荐的就是普罗跟逆命。玩真正的一个先决条件就是你开局要有逆命，又或者是说家里后可能这些角色呢进牌是比较多，也在玩这套阵容，就是也比较到完全的一个铁头。然而如果你是为了这套阵容去选了一个逆命这个传说的话，其实你也可以去摇摆其他的一个阵容，像说斗士、蛇女啊以及魔斗。这也是我观察到老王常有的一个转正的思路，所以大家可以多参考一下。第二个呢，就是当然也要是没有同行，不管是任何一个赌阵，其实就是没有同行最好。就算是玩菜哈，其实没有同行最好，但有些阵容就是没有办法，它就是一定会有同行的。阵容过渡的部分，前期就是连败、最大化经济、3者的时候去升上6等，6等是一个非常关键的时机点。在这里的话，去组出一个4爆冲3D 马西亚的羁绊，在此卡着40到50元的一个经济。然后慢追我们的逆命塔利亚、加里欧来到3星。没有加文的话呢，你其实就是先用凯尔，然后凯尔这个位置呢，你其实可以把它换成波比。基本上凯尔呢就是来破这个魔防用的，所以如果你有星火的话呢，就是换成波比嘛。等到逆命跟加里欧都来到3星之后，就可以去升上7等了。7的话就是补上斯温跟加文阵容就大功告成了。而我对这个阵容呢有一个最新的理解，就是我在有一场没有打赢科加斯的对局之中，突然悟了，因为我发现打科加斯，因为这套阵容我觉得真的很难打那种大坦的阵容，尤其就是科加斯，因为它的坦度实在太高，而且通常科加斯都会去出反甲龙爪，然后就完全天克逆命这一套。这个时候你的暴走法师就是要得缩脚摆，集中火力，争取开局直接秒到敌方的一个前排，让他连呼吸的机会都没有。所以呢，蛮推荐大家可以这样子去做摆位。当然啊，如果说你今天打到的是一些有加文的人呢，你可能就还是300也是 OK 的，就看你对局的对手是什么样的一个阵容，然后去做一个灵活的摆位。好，以上就是我跟天晴真的花了非常多心力在整理的这个阵容大集结哦，希望有帮助到你们。那今天明天周二晚上4点，拜拜。对，今天有比赛，晚上6点记得来看。好，拜拜。
A problem from International Math Olympiad. International Math Olympiad is a 2-day, 9-hour test with 6 problems. It's a very difficult test. But those years, you know, I think it started in 1959, and not very many countries were participating. I think currently it's about more than 80 countries participating. Anyways, so let's go ahead and take a look at this problem. This is a radical equation. The square root of x squared minus p plus 2 times the square root of x squared minus 1 is equal to x. P is a parameter, so as p changes, the solutions change. We have to check a few things. So let's go ahead and start by looking at the radicals. First of all, if you look at the left-hand side, it's the sum of two radicals. If x is real, then of course they need to be greater than or equal to 0, so their sum, which is x, is also greater than or equal to 0. So that's our first requirement. And then we have to look inside the radicals. X squared minus p needs to be greater than or equal to 0. This implies that x squared is greater than or equal to p. Great. And then we also need to check this one, x squared minus 1 needs to be greater or equal to 0, which implies x squared is greater or equal to 1. And this implies two things. Either x is greater than or equal to 1, or x is less than or equal to negative 1. But since x must be greater or equal to 0, we are not going to be able to use this condition, so we have to go with x is greater than or equal to 1. Okay? Now, and of course, this basically gives us x is greater than or equal to 1 because that already covers the positivity. Okay, so let's go ahead and square both sides under those conditions. We're going to get something like this when we square both sides. X squared minus p plus 4 times x squared minus 1 plus 4 times the radicals, square root of x squared minus p times the square root of x squared minus 1, and that's going to equal x squared. The first thing you should check is x squared, that cancels out, and now we end up with something like this. Let's go ahead and do the following. Keep all the radical expressions on one side and put everything else on the other side. So we're going to get something like this. 4 times the square root of x squared minus p times the square root of x squared minus 1 equals p plus 4 minus 4x squared. I just distributed the 4 and negated everything to put on the right hand side. Now, we gotta look at something else. Because we have a radical expression on the left, which is kind of like the product of two radicals, which have to be greater than or equal to 0, and that implies that this needs to be greater than or equal to 0. And what does that give us? Let's check. P plus 4 minus 4x squared needs to be greater than or equal to 0, and from here we immediately get 4x squared is less than or equal to p plus 4, and upon division by 4, x squared must be less than or equal to p plus 4 divided by 4. That's another condition you need to check. Okay, under those conditions, let's go ahead and square both sides again. And that's going to give us the following. 16 times x squared minus p times x squared minus 1. And then that's going to equal the expression, that expression squared. Let's go ahead and square it right away. I'm going to take this as a quantity, p plus 4 squared, and then minus 8x squared times p plus 4, and finally plus 16x to the 4th power. So we basically treat it as a minus b squared, use that identity, which is easier than a plus b plus c squared. It's a little shorter anyways. So now, when we distribute this and then multiply everything by 16, we're going to get something like this. Kind of, we got to keep unwrapping this. 16x to the 4th minus, and I'm going to, kind of factor this and keep it organized. P plus 1x squared plus 16p. Everything is multiplied by 16. And then on the right hand side, we get p squared plus 8p plus 16. And then I'm going to keep this like 8 times p plus 4x squared, because I'm going to put together the coefficients of x squared as a polynomial, plus 16x to the 4th power. Take a look at this. This problem is really nice because things cancel out. Okay, great. 16x to the 4th cancel out, and then we end up with sort of like a quadratic equation. Let's go ahead and take a look. 16 p plus 1 x squared. Now I'm going to put everything on the right hand side because that's where x squared is going to be positive, and then I have this and I have that. I'm going to subtract those, and then I'm going to write this. You could keep it as a p plus 4 squared, but I'd like to expand it. and then this is equal to 0. Great. Now this is our quadratic, but we're going to write it in a different way. So let's go ahead and subtract the coefficients of x squared here. 16p minus 8p is 8p, and then 16 minus 32 is negative 16. That's going to be the coefficient of x squared. And then from here, so you can do a couple different things. You can put this expression right here on the right hand side, and you know what, I think I'll keep it as a perfect square. So let me go ahead and write this as p plus 4 squared. I probably should never expanded it, but anyways, and then put it with a minus sign, and then my goal is to isolate x squared. Obviously this is the most important part, and I kind of messed up, so I think, oh yes, I forgot to subtract something, because this gives me minus 8. There you go. Okay, yeah, exactly. When I subtract it, it should be p squared minus 8p plus 16, and now this becomes p minus, let me go ahead and back up to fix this, okay? So plus p minus 4 squared is 0. Okay, now it's good. Now we're going to, okay, my goal is to isolate x squared. How can I do that? In a different way, a couple different ways, but let's put the p minus 4 squared on the right hand side, the minus sign, and then divide both sides by 8p minus 16. And of course you don't want a minus sign in front of this, so let's go ahead and negate top and bottom. That gives us p minus 4 squared divided by 16 minus 8p. Make sense? This is super duper important. We're going to take a look at it towards the end. But this is what x squared is. So we have been working with inequalities. Now we got an equation, right? So let's go ahead and check each of these requirements. So we had 3 requirements, as hopefully you'll remember. We do need x squared. Oh, by the way, x squared, we can use this instead of that, so forget about it. Let me go ahead and list those requirements, and then we're going to use that. So first requirement, I want to use x squared is greater or equal to p first because of the first radical. And then my second requirement is going to be x squared is greater or equal to 1. And the third one is x squared is less than or equal to p plus 4. Remember, this comes up after we square both sides. And now I got to check all of these requirements. But those are going to be easy to check. Let's go ahead and do it. So the first one, x squared is greater or equal to p. From here we get something like p minus 4 squared divided by 16 minus 8. Remember, I got a value for x squared. I'm going to just compare it to p. So if this is greater or equal to p, now I got a single equation. This is an inequality. Subtract p from both sides, arrange the terms, and here's what you can end up with. I'm going to keep that story short so we can immediately get to the answer. And then this is the inequality we get from here. And this implies that since the top is a perfect square, 16 minus 8p must be greater than 0. This implies that p is less than 2. Okay? It can't be.
Job's done. 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 Job's done.
Someone call for the doctor?
Out with it.
MCCLXXXXVI. Job's done.
Point the way.
Enlighten me. It has begun.
I stand ready.
ready to work.
Upgrade complete. Research complete.
Bravo, mesdemoiselles. Camille Thomas, nommée cette année dans la catégorie Révélation soliste instrumentale. Et Béatrice Berru au piano. Bravo et merci.
I am prepared.
Job done.
Walk away.
Upgrade complete.
I believe that's a given.
Upgrade complete. Job done.
YouTube Premium 不只是零广告，立即试用1个月。
done. Upgrade complete.
Have you reached a limit? Left the university.
My bidding. I cannot summon brothers. Out.
Job's done.
My bidding.
Upgrade
I am
complete.
prepared.
Upgrade complete.
Point the way.
My bidding.
Bravo, mesdemoiselles. Camille Thomas, nommée cette année dans la catégorie Révélation soliste instrumentale. Et Béatrice Berru au piano. Bravo.
YouTube Premium 结合零广告 YouTube 与 YouTube Music 应用程式，免费试用1个月。
Job's done.
My bidding.
Upgrade complete. Upgrade complete. Research complete. Research complete. Job done. Upgrade complete. Upgrade complete. Job's done. Job's done. Upgrade complete.
Enlighten me.
Heed my
Bravo, mesdemoiselles. Camille Thomas, nommée cette année dans la catégorie Révélation soliste instrumentale. Et Béatrice Berru au piano.
Job's done.
Bravo.
Job's done.
Et merci.
Upgrade complete. Build more farms.
Enlighten.
Build more farms. Build more farms. Build more farms. Build more farms. Upgrade complete.
My brothers.
Job's done. Job's
YouTube
done.
Premium 是零广告 YouTube 外加 YouTube Music
Upgrade
Premium
complete.
免费试用1个月。
I pledge my loyalty.
Research complete.
Point the way.
I bid you.
Upgrade
Has
complete.
begun.
Job done. Job done.
Enlighten me. We demand additional lumber.
Upgrade complete.
Out with it. Enlighten me. I am prepared.
done. Job's done. Upgrade complete.
Out with it.
Upgrade complete. Upgrade complete.
I bid you. No one shall be the wiser.
Upgrade complete. Job's done. Another round. Build more farms. Job's done. Upgrade complete.
I am prepared.
YouTube Music 是 YouTube 制作的音乐应用程式，让你点播超过8000万首官方歌曲，能一直听到你的增，大概10代以后的曾孙出生。试试 YouTube Music Premium， 马上免费试用1个月。